Okay, now we go to work. Yeah. So in this subtopic, we will discuss about work, energy, and power, and what is the relationship between all these three terms used in this subtopic. Okay, so the first thing that we have discussed before holiday is work. Yeah. So I will repeat again to explain what is the meaning of work and how work is calculated. Yeah. So now the meaning of work, or in BM we say it as a kerja. Yeah. The symbol represent work is W. Okay, is defined as the product, hasil from the multiplication relationship between force and displacement. Yeah? And the condition for the displacement is must be in the direction of the force. In the direction of the force. If the force is in the direction of horizontal way, so the displacement must follow the direction of that force. Yeah. So when force and displacement is multiplied, so we will get the product that is work. Yeah. So this is the simple explanation or definition for work. Yeah? So in order to find what is work for any activity, so you have to find force and multiply it with displacement that taken place, yeah, in the direction of the force. And the unit for this work is joule. Yeah, joule, J. Yeah. Okay, now if we say that 1 joule, yeah, 1 joule of work is done, so means that 1 Newton of force is applied to an object over a distance of 1 meter. Yeah. So a work is done with a unit of 1 joule, yeah, when 1 Newton of force is applied or is acted on any object with a distance of 1 meter. So that is the how to explain about the work and its unit. Yeah. So work, the unit is joule. So 1 joule will represent 1 Newton that act on any object with a distance of 1 meter. Yeah. Okay. So that is work. Yeah. Okay. And then, so how to understand this work? Yeah. How to calculate work in our daily activities. So for example given here, yeah. Okay, so you must know from here, this woman, okay, try to lift this object, yeah, from the floor, and with the weight 20 Newton. Yeah, weight of the load of this object is 20 Newton. So when this woman lifting an object vertically through a height of 1 meter, so this is the distance from the floor until the maximum lifting is 1 meter. So we can say that the work is done by this woman. So how to calculate the work? So we have to calculate the force that being used to lifting this object times with the distance from the floor. Okay, the distance given here is 1 meter. Yeah. So what we have to do is we times 20 Newton with 1 meter. Yeah. So we will get the work done. Yeah. Okay. So example given here, we can write it like this one. Okay. Okay, work. Okay. Okay, work is done when force that act on any object over a distance, yeah, over a distance in meter. Yeah. So now, example given in the diagram in the textbook. Okay, when an object okay, and then this object is okay lifted up. Okay, so here 1 meter, and then the load, the weight of this object is equal to 20 Newton. Yeah. Okay. So now from the floor here, when this person lifting the load 20 Newton with the distance of 1 meter, so we can say that work done by this activity, work done by this activity by this person, work done by this person is force. Okay, so where we can get the value of force? Okay, so from here, force we get from the weight of an object. Yeah, weight of this object times the displacement, distance to lifting up the object. So now, force we can take from the weight of an object. So the weight of an object is 20 Newton. Yeah, times distance in meter. Distance in meter. So given here is 1 meter. So 1 meter. So the answer here will 20 Newton meter. So the work done by this person in this activity is 20 Newton meter, that equal to 20 joule. Yeah. So Newton meter, the same unit is joule. So now from here we must know that 1 Newton meter equal to 1 joule. Yeah, 1 Newton meter equal to 1 joule. So this is how to calculate the work done by this activity. Yeah. So work will equal to force times displacement. Yeah, the distance taken place by the object. Yeah. Okay. So that is the simple explanation about how to calculate work. Okay, the next example given is like this. Activity B, pushing a trolley over a distance of 5 meters with a force of 10 Newton. Okay. Activity C, pulling a drawer over a distance of 30 centimeters with a force of 2 Newton. Okay, so from the formula given here, work, so how to find the value of force here? So we must know that work is defined as the product of force and displacement. So we can know the displacement, the distance, taken place when the work is done. But how to find the value of force? So it will depend on the situation. For this first example, you can see the force is exactly weight of an object. Okay, weight of an object. Why? Because any object that move, so that object will be considered as the force in this definition. Because this object is moving, and the moving of this object with their own weight. So their weight will represent force. We represent force. And what you have to understand is weight is exactly the combination of mass time gravitational force. Okay. So any object will have their own mass. Any object will have their own mass. So now, mass of this object exactly is 2 kilogram. But because of the effect of gravitational force that equal to 10 Newton or 10 meter per second, so when we multiply mass and gravitational force, so we will get weight. So when mass times gravitational force, we will get weight. So when we get weight, so that is the force of this activity. So in order to find force, so you have to find the weight of the moving object. So make sure that that object is moving, or involved in the movement. Any object that involved in the movement of the work done, so the weight of that object will be considered as the force. The weight of object will be considered as the force in this formula. So this is how to find the value of force in order to calculate work. So same thing here. If we can see activity B and activity C, so we can see that the force is 10. For activity C, the force is 2. Okay. So this one, we can see that given here, okay, 10 Newton. Okay. So this 10 Newton exactly, you can see from here, in this diagram never stated any information about the weight of this trolley and also the weight of this boy. Yeah, it only says about force of 10 Newton. So because when this boy push this trolley and this boy also will move. Yeah, so exactly the force is the combination of this boy weight and also the weight of this trolley over the distance. Yeah, so the summing up of the weight of this boy weight and also the trolley is 10 Newton. Yeah, same with this one, activity C, just stated here force of 2 Newton. Yeah, force of 2 Newton because the hand that is being used to pull a drawer is also moved, yeah, over a distance with a weight of the drawer. So 2 Newton is exactly the combination of weight of hand and also weight of a drawer. Yeah. Okay. So that's why given here only value of force. Yeah. Okay. So we can look into more detail about this one from this example 1. Yeah, you can see from example 1. Try to understand how to calculate work. Yeah, so look at here, figure 7.2, this one. Okay, 7.2 shows a student weighing 400 Newton carrying a load of 100 Newton while climbing a flight of stairs of a vertical height of 3 meter. Calculate the work done. Okay, so from here, okay, now look, this student will move along this stair. Okay, he himself will move along and carrying a load, an object that weight 100 Newton. Yeah? So the weight of this boy is 400 Newton. Yeah? 400 Newton. Yeah? So you must remember, mass, the unit is kilogram. Yeah? Kilogram is unit for mass. Weight, the unit is Newton. Yeah? Berat, so exactly berat is weight. The SI unit is Newton. Because weight or berat is affected by the gravitational force. That's the thing that you must understand. So now you look, this boy, the weight of this boy is 400 Newton. And the weight of this object that is being carried out by this student is 100 Newton. So because of this boy and the load is moving along, yeah, so we have to combine the weight of the boy and weight of the object. So it will become 400 plus 100 Newton, so become 500 Newton. And then times what is the distance? Is 3 meter. Yeah. So this is how to find the force in work. Yeah. Okay. So and then we get 1,500 joule. So you have to understand the concept of work done. If the object is moved alone without the movement of the any human being, so we will only consider force based on the weight of an object. But if the movement of an object is combined with the movement of a people, so we have to include into the force the combination of weight of person and weight of an object. So same as given in this example 1. Please try to understand this one. Okay, next, you can see example 2. This one. Okay, this example 2. This boy, you can see, only lifting the box from the floor to the top of the cupboard. Only the box is moved, but this boy is not moved. It just stand there. So in order to calculate the work done by this boy, so we only take force from the weight of this object only. That's why the calculation here is, okay, because given here a box mass is 10 kilogram. The mass of this box is 10 kilogram. Okay, so now what we have to take is weight of this box. So in order to find the weight of this box, so we have to calculate or multiply it with the gravitational force that acting on this object. So now 10 kilogram times 10 Newton. So the weight of this box is 100 Newton. So 100 Newton will become force to calculate work. So that is the thing that you must remember. So force is a value of weight of an object. Okay, now 100 Newton times 2 meter, because the height here is 2 meters. So we will get the work done by Ali is 200 joule. Okay. Okay, same thing for the example 3. This one. Okay, given here the cement weighing is 300 Newton. So the weight is given here. So no need to multiply with the gravitational force. So we just put here 300 Newton times the height, 10 meter. So we will get 3000 joule. That is the value for the work done in this example 3. Okay, so we look into this diagram given at the right here. Is work done in the situation shown in the photograph. Okay, this person trying to push, okay, this wall. So can we consider work is done? No, because even though this person have their own energy, have their own force, but the wall is not moved. Because there is no movement, so we cannot say the work is done. No work is done in this situation because the object that is being pushed is not moved. So the condition for the work is done is must have force and then must move. There is a distance. There is a displacement of that object. Must be a movement for that object. Okay, now we look into the energy and power. Okay, what is the meaning of energy? What is the meaning of energy? Here, energy is defined as the ability to do work. Okay, ability to do work. So means that here, in order for us to do a work, so we must use energy. So whatever work that we have done, exactly the value of the work that we have done is the same as the energy that is being used by us. Okay, so that's why energy is the ability to do work. So when we want to do any work, so we require energy. So what is the value of energy that able us to do a work? So whatever work that have been done, so that is the value of the energy. Yeah. Okay, so the SI unit for energy is joule, same with work. Yeah. So without energy, work cannot be done. Yeah. So when a force of 1 Newton is used to move an object over a distance of 1 meter in the direction of the force, so 1 joule of energy is used. So you can see from here that so whatever the value of work is done, so that is the same for the energy that is being used. Yeah. So we require energy to do a work. Yeah. Okay, now based on that, yeah, we have next term, yeah, istilah yang lain, that is power. Yeah. So what is the power? Yeah, power is defined as the rate of doing work. Yeah. So when rate of doing work means that when we are doing a work, so we compare it with time, so that is a power. Yeah. So power will consider the time taken in doing a work. Yeah. So for example, how many time taken when we try to climbing a stairs, for example. Yeah. If we are slow or faster. Yeah. So if we have a high power, so we will do a work in a short time. If we have a less power, means that we have to take a long time, yeah, to do that work. So the rate of doing work is exactly the definition for power. So what is the unit for power? Okay, this is the unit watt. Yeah, the symbol is W here. Yeah, the unit is watt. The symbol for the unit is W. Yeah, so what is the unit for power? So what we can say, when 1 joule of work is done in 1 second, so power of 1 watt is used. Yeah, so 1 watt is equal to 1 joule times second. Yeah, so the formula here, power is equal to work done divided by time taken. Yeah, okay, so you have to remember this one. Okay, so you have to remember this formula power. Yeah, so power is a rate of doing work. So the formula is power work done. The unit is W divided by time taken. Time taken. So that is the power. So this is a rate of doing work. So we compare it with a time. So now we look into the example given. Okay, so for example, on how to calculate power. Okay, so look into this one. A monkey activity D, activity D. A monkey weighing 50 Newton climb a height of 3 meter up a tree in 20 seconds. Okay, activity D. Activity D. Okay, a monkey weight equal to 50 Newton. Okay, the weight of this monkey is 50 Newton. And then the height is 3 meter and it takes about 20 seconds. Yeah, 20 seconds. So, how to find the power of this monkey? The power of this monkey to climb a tree. So, based on the formula given, so we have to find the work done first. Okay. So, work done by this monkey is force time displacement. So, what is the force? So, I have told you how to find the force for this activity. So, this activity, okay, is the activity of this monkey climbing a tree. So, means that the force is based on the weight of this monkey. So, now the force is 50 Newton. That is the weight of this monkey. So, you have to remember this one. So, force we can take from the weight of any object that move. Weight of any object. So, easy to understand. So, force is weight of object that move. Weight of object that move. Times S, displacement is based on the height. So 3 meter. So we will get about 50, 100 and 50 Newton meter. 150 Newton meter, so equal to 150 joule. So same unit. Same explanation. So now what is the power of this monkey when trying to climb a tree? So the power is work done divided by time. So work done is 150 joule or Newton meter. Divided by time is 20 seconds. So we will get 77.5. 7.5. Okay, the unit is joule per second. Joule per second. Based on this one, joule per second. Okay. That is the first example on how to find power from the work done. So how many of you? 27. 27. Amira, Atika, Ismail, Ahmad, Eric, Islam, Lawrence, Sophie, Lawrence, Rania, Sophie, Loro Monama, Loren Diana, Putri, Dewan, Benisha, Owen Hana, Wan Muhammad Adi. Okay, only 27 of you until now. 27. So means that how many of you? 6. 6 absent. Okay, 6 absent. 29. Okay, so that is the first activity D, calculation of power. Okay, now look activity E. Activity E. Okay, this person pull a box up a smooth ramp from A to B, from A to B, pull a box with a force of 30 Newton over a distance of 2 meter in 5 seconds. Okay, so just given here, you can see, just given only give a force, the value, direct information, force of 30 Newton. So in this thing, we can calculate directly. Okay, so based on that, okay, sorry. Okay, so for this example, activity E, activity E, okay, activity E, so because force is given, in the question, that is 30 Newton, and the distance is 2 meter, distance 2 meter, and then time is 5 seconds. So this one is very easy. Just calculate work. Okay, work is force time distance. So we get 30 Newton times 2 meter. So we will get 60 Newton meter, or 60 joule. So the power is work done divided by time. So the work is 60 Newton meter divided by time is 5 seconds. So from here we will get okay, so we will get about 12. Okay, 12 joule per second. So this one 12. Okay, Newton meter per second, or this Newton is joule per second, power of -1, or 12 joule per second is equal to watt. So because the unit for power is watt, so we can say 12 watt. That is same with the 12 joule per second. So this is how to convert the unit given during the calculation. Okay, so next activity F. Okay, this man, lifting an object, a object with weight 150 Newton. Okay, so activity F, the weight of an object is 150 Newton, and then height of 1 meter, the height taken place is 1 meter, and the time is 0.5 second. Okay, so how to calculate the power? So same thing, we have to find the work done, that is force times displacement. So what is the force? Okay, force we take from the weight of an object, that is 150 Newton, because the person is do not move. the person do not move. So we take only the weight of an object times 1 meter. So we will get 150 Newton meter or equal to 150 joule. So the power is 150 joule divided by 0.5 second. So we will get the answer is 300 joule per second or equal to, we convert it into 300 watt. So this is how to calculate power in calculation of this any activity. Okay, so we look into this formative practice 7.1, question number 4. Question number 4 here. Okay, before we dismiss. Okay, so figure 1 shows an electromagnetic crane lifting a load weighing 2,500 Newton to a height of 4 meter. Okay, so you can see from here, crane lifting a load weight 2,500 Newton. So question A, calculate the work done by this crane. Okay, so how to calculate the work done? So work equal to force time displacement. So what is the force in this activity? Okay, we take from the weight of an object that is moved. So what is the object that is being moved? The load itself. So that object itself. So the weight of that object is the force in this calculation. So 2,500 Newton. Okay, so very easy. Just take from the weight. Hanya ambil daripada berat objek tersebut. Times okay, 4 meter. 4 meter. So we will get about 10,000 Newton meter. 10,000 Newton meter or 10,000 joule. Equal to 10,000 joule. So Newton meter is equal to joule. So you must remember that. Okay, B. How much energy is used by the crane to lift the load? How much energy is used? So how to answer this one? So as explained previously, that energy used, energy is the ability to do a work. So when any work is done, so the value of that work is exactly the value of energy to do that work. So now for question B, energy used is same with the work done. So the work done here is 10,000 Newton meter or 10,000 joule. That is how to calculate. So normally joule, normally when the value is more than 1,000, so normally we convert it to kilojoule. So 1,000 joule is equal to 1 kilojoule. So we can convert it to 10 kilojoule. Okay. C. If the time taken by the crane, C, if the time taken by the crane to lift the load is 1.2 minutes, how many seconds? 60, 90 seconds. Calculate the power of the crane. Calculate the power of the crane. So, this to find power, work done. Okay, better for you to write again and again the formula in order to remember the formula. Work done divide by time taken. Okay, so by writing the formula every time you want to calculate anything, so you can remember that formula. Very easy. So now work done have been calculated previously. So 10,000 joule or Newton meter joule divide by time taken. So time taken here is minutes. We can convert to second and 90 second. So just calculate this one. Yeah. What is the answer for this one? So 10,000 times 9. Okay, what is the answer? 1,000 times 9. Oh, we get 111.1. Yeah, so 111.1. So the unit is watt. Yeah, so this is the power for this screen. Yeah, 111.1 watt. Yeah, so this is the way, the method used to calculate power and also to calculate work done. Yeah, so the relationship between power, energy, and work is based on this formula. Yeah, power is equal to work done divided by time taken. Yeah, so that is the explanation about work, energy, and power. Yeah. Okay, so for tomorrow, we will continue to the subtopic. Okay, subtopic 7.2 for tomorrow morning. 7.2, we will discuss about the potential energy and kinetic energy. So I hope that you can understand the concept of work, energy, and power, and how to calculate the term work and also power when you try to answer the question based on this subtopic 7.1. Okay, so before we dismiss, so 28, 29. Okay, same. So it means that 27 of you attend today lesson. 27. So means 6 of you are not present today. Okay. Okay, so that's all for today. Thank you very much for your attendance. Okay, please write your name in a science group. Okay, thank you very much. We meet again tomorrow for subtopic 7.2. Okay, thank you. Okay, Owen cannot stop recording. Okay, after this, please send